Okay, so let's start discussing the rest of the questions. So we had done till ninth of the question, 9 questions till now. So I'll be resuming my discussion from the 10th one. Okay, so 10th one question reads that the radius of the Martian orbit, Martian means it must be talking about Mars, around Sun is 4 times the radius of the orbit of Mercury. So Mars has 687 Earth days as its year, right? A year is what, the time taken to complete one revolution around Sun, right? So Mars basically takes 687 Earth days. So then, which of the following is the length of the 1 year of Mercury, right? So let's start discussing. So 10th question is what we are up to. Okay, just a second. Okay, so 10th question. Okay, before this, I think there was one question that we had discussed. It was about this one, right? And the very first question that we had taken up, I think there was something that we did around all this. I think I took it as a circuit wherein one thing is connected this way, the other thing is connected this way, the other circuit. I think 5 resistors were given to us in this format, right? And the wires were coming out from this way. So we definitely know that they are not in series, but I think we discussed it without giving a thought that this was not connected over here. Actually, it was connected at the middle of these two resistors. So even if we calculate after that, you know that these values were giving me approximately 2 as the answer. So I think whatever calculation we did, we were not precisely landing towards 10 ohm. So I think that 10 ohm mistake was happening because we did not realize that this was a Wheatstone bridge, right? So Wheatstone bridge fundamental, if we apply that, if the opposite resistances, if they multiply to the same number, then it is a balanced Wheatstone bridge, and that's where we ignore the middle one. So I think the same values were provided to us in this question as well. So I believe if you consider it as a balanced Wheatstone bridge, this value will definitely come out to 10 ohm. So once you have this as 10 ohm, so once this exactly becomes 10, so answer would have been 0.5, which we were also extrapolating using this number. Although we were wrong in considering it to be a series kind of situation, because we did not realize the kind of place it was connected. Yeah, but it is a balanced Wheatstone bridge, so our answer was still coming to be zero point 0.5, which is, I think, I have already discussed. Okay, so let's start discussing the next questions. 10th question, you know the radius of Mars is given as 4 times of Mercury, right? Radius, right? If that is the relation, we know that time comes out to be 2 pi r by v, right? And we know that this thing, if r is the distance from the center, right? So we know root g m by r is the velocity. So we know 2 pi by root gm, and its power will be r to the power 3 by 2. So we know that t square comes out to be proportional to r cube from this relation, right? Which is also mentionable from the Kepler's law. So if we consider such a relation, so we know that time period of which describes the year of a planet, right? So that for Mars divided by that for Mercury will be proportional to the radius of Mars upon radius of Mercury. Mercury to the power 3 by 2, if I use this proportionality here. So I think I have been given that this number is 4. Okay, so 4 to the power 3 by 2 comes out to be 8. So I think the year of Mercury, that is the number of days, should be Mars number of days divided by 8. So I think the number that we are given is 687. 687 divided by 8. If I calculate this number, it should come out to be 8, and then 47, if I consider approximately as 48, then that will be 86 days or something, right? If there is a option like that. Okay, 86. Okay, I think still the best answer that we are getting in this case will be this only, right? Okay, how do we highlight? Okay, I think that is what we are getting. I don't know how this again goes, right? I think there is some issue with the highlighting part here. Okay, I'll still write the answer with the same numbers, right? Same line I'll use here to finally conclude the answer. Let me use this one, okay? So let's get started with the second one. That is, to an AC power supply of 220 volt at 50 hertz, a resistor of 20 ohm, reactance of capacitor is given as 25, and the inductor's reactance is also given as 45, are connected in series. The corresponding current in the circuit and the phase angle between the current and the voltage is, right? I think this is very direct question about the RLC circuit, so which is in series, so that need not take too much time in terms of solving it. So let me just take the values and just do it for you. 20, 25 and 40, or is what, 45, right? Okay, so let me just take you to the 11th one. Resistance is 20, then for capacitor it is 25, and then for inductor it is given as 45, right? If I try to draw these values as a phasor, you know, XL, XC, right? So if I take this number, definitely I know this is given as 45, this is 20, this is 25. So if I have to find the net here, that will lead me some 5 over here, right? Because I know 45 is greater than 25. So I can calculate this tan phi easily by writing it as 45 minus 25 divided by 20. That should give me 5 by 4. So I believe this number should help me wherever required. I think what was asked, I was asked what is the current in the circuit. So for current, the effective impedance of the total reactance of this will be given as R square plus XL minus XC whole square, giving all the phasor treatment. So I think this number should turn out to be 20 square plus 45 minus 25 whole square. So I think that number will make it how much? 400 plus 25 whole square will give me 625, right? So that should give me 1025, and that becomes somewhere around 4 into 5, so that is a square of 45. Is it right? 400 plus 25 whole square, right? So I think 25 whole square gives you 625, and then if I again add them, it will give me 45 only, right? I hope this makes sense, because again, if it was a triangle with the 20 versus 25, so that would mean it is 4 times, it is 5 times, and if I make them squared, it should again give me 9 or something, or what? No. I think I should check the calculation again. 25, that will be 20. Okay, right. That's why I was thinking how can it end up giving 45. So that was 20, so 20 whole square will again give me this, so that should give me for 20 root 2 as the answer, right? So I think, yeah, this helped, so no longer required. So I think the current, if we have to derive, the voltage is given as 220. So 220 divided by 20 root 2 That takes me somewhere near 11 by root 2. 11 by root 2 can be written as 11 root 2 by 2, which means somewhere around 5.5 into 1.414, you know, and that number should be how much? I should check with the options, I guess. So I think 15 is not possible, and possibly the answer will be from these two, that is 7.8. And if I check the angle here, so what should be the angle? I think in angle also we made that mistake, right, about subtraction. Yeah, so this was angle will be 4 by 4, right? 20 by 20 will come, so it will be 1. So angle comes out to be 45 degree. And if I take care of the lag case here, we know the lag also is decided by the phi. So that phi, once it goes in the denominator, it will be keeping the voltage like lagging in terms of voltage lagging in terms of with respect to current, or I should say that the current should be lagging with respect to voltage, because once uh, reactance is going towards the side of inductor, so definitely inductor will be having much more properties working for it. So that's why the current should be lagging here, right? Definitely inductor is like that only, that it let the current comes in picture later on. So that's why the current will be lagging. So that lag can be easily calculated from this number, that is 45 degree. So I think the answer for this case should be this option number C, right? Okay, so now coming to the 12th one. Wire of resistance this is cut into 8 equal parts. From these, two equivalent resistances are made by adding 4 of these together in parallel. Then these two sets are added in series. From these pieces, two equivalent resistances are made by adding 4 of these together in parallel. Okay, so that means R is cut into 8 pieces, means the resistance of 8 pieces will become R by 8. Now that R by 8, okay, I think it is a very trivial question. Once you cut R into 8 pieces, that will give you 8 R by 8 resistances. From these 8, you take 4 and 4, where all these 4 are connected as parallel. This is again taken as parallel. So I think once you take them into parallel, so again their individual or their effective resistance overall will come out to be R by 32, because in parallel it decreases. So R by 32 will be the answer for this also overall, right? Now what they are doing with this set, then these two sets are added in series, so the net effective resistance will be, I think now in resistance when they are connected in series, so the overall answer for this case should be R by 16, right? So the answer for this case will be R by 16, which we can see, right? Okay, now is the question related to gates. So I think this is a NOR gate, this is a NAND gate, and this is an AND gate. Then let's operate it. Here also AB, here also AB. Okay, I think for 13th question, from above, A and B are getting operated by this gate, right? Which gives me OR result, right? So OR is given this way. Now from the other side, AB if treated, so the treatment will be done over NAND. So NAND is represented as this, right? First and then not of it. Now this together is fed to AND gate, right? AND gate does what? First, it will be just doing a simply a AND between these two operations. So AND is denoted by dot. So we know that we have to apply what kind of operation between them? Doing a AND, right? And dot is nothing but AND, right? So this is what will be the answer. Now to simplify this, we can apply the De Morgan's theorem, what is also valid in your chapter of sets, basic sets, if you have idea about. Otherwise, these logics are already taught in the class, so I think this can become something like this, right? And if I apply De Morgan over this, where also inside there is a AND happening, so this will become A naught or B naught, right? And there is a AND happening between them. So if I operate and over these, so I think I'll be ending up with such a expression, and the other term will be, I think I can multiply with these individual terms, so that is allowed algebra here. So, and now using the associative property of the booleans and these gates, I think you know it very well. When you once you take a and between same thing with the same thing, your answer comes out to be just exactly same. So the overall result of this will, these two getting and will become a bar dot b bar, right? And the same will be happening for these two, so a bar into b bar. And again, if you see overall also, they are exactly same. This is what exactly looks like this, right? So once you operate them together, the overall answer is not going to be different, it is going to be the overall answer. I am using here this simple property of two gates operating with the and on each other. So the overall result for this is again a d operating on over a d gives you d only, right? So that's how we can treat the answer, and the answer for this will become if I again apply De Morgan's theorem, you can see it will look like this, right? It is a reverse De Morgan that I have done here. So using that, I think you can believe this is nothing but NOR gate. So this is what should be the answer, the NOR gate thing, right? Okay, let me take it wise clearly. Okay, so this is NOR gate only. Okay, so now let's just continue to the 14th one. Let's read the question. Two identical charge conducting spheres A and B having their center separated by a certain distance, charge on each sphere is q, and the repulsion between them is F. Okay. Third identical uncharged conducting sphere is brought in contact with the sphere A, and then with the B, and then finally removed. The new force between the spheres A and B, radii of A and B are negligible compared to the distance between them. Okay, so that compared to the distance of separation between them, so that for calculating force between them, they can be considered as a point charges. Okay, so they are like they want you to use Coulomb's law here, which is what is written in this whole bracket. You can see, right? So the question says that question is saying that there were two spheres on which q and q charge was there, and they were identical. Similarly, there was another sphere which was actually conducting, right? So this was conducting, and this was first taken towards A and was taken in touch with this. So once you touch it, the charge will start flowing between them and will stop once the charge will be just equal between them, because the charge stops when the potential matches, and potential in this case will match when the charge will be equal, because they are exactly identical, right? So I think once that will be happening in the very first step, so this charge will become I think I should not write it here. This q will become q by 2, right? And this will also again q by 2, right? Now in the second step, this is taken in contact with C. So that is the second step. Again, now once they are in touch, where will this charge flow stop later on? So overall charge in this case will become q plus q by 2. So that is nothing but 3q by 2. So it will only stop when it is become equally on both the things. So this will finally become 3q by 4, and this will finally become 3q by 4. So the final things are given in these boxes, right? So these are the, and now this C thing has been removed from the scene. So once you have taken this conducting sphere away, the charges left are 1 by 2 and 3 by 4 on this one. But the distance I'm assuming to be same, because they want to take you some kind of a ratio, because they want you to express the new force in comparison to the old force. So the old force was kq by r square, but the new force, which was called as F, but the new force is called as kq by 2, into 3q by 4 by r square, which I can easily say it is nothing but f into half into 3 by 4, which will be 3f by 8, right? So I think the answer is going to be this one, right? So let's just continue discussing the questions in this sequence. This 15th question is asking you about the vernier caliper. So it says the diameter of a spherical object being measured with the help of vernier caliper. Suppose for vernier scale, 10 divisions of it are equal to 9 main scale divisions. The least division in this case of our main scale is zero point 0.1, and the zero of vernier scale is at 0.1 when the jaws of vernier calipers are closed. So when the jaws of the vernier calipers are closed, then also main scale is reading zero point 0.1. That means in this vernier caliper there is an error, right? And that is a positive error because it is already above zero. Even when the jaws are completely closed, so even then it is sitting at 0.1 centimeter, so definitely it is a positive error. So if the main scale reads for the diameter as 5 centimeter and the number of coinciding vernier division becomes 8, then the measured diameter after zero error correction. So zero error correction means that error that was actually happening at 0.1. So I think for this case we have done it multiple times. When 10 main scale divisions matches, right, it says that 10 how can main scale divisions be smaller? The main scale divisions are bigger, right? So this has to be VSD. So 10 VSDs are going to match with the 9 MSDs. So I know that 1 VSD will look like 9 by 10 of main scale division, where main scale division for this scale is given as 0.1 centimeter, right? So this becomes 0.9 centimeter, and we know that for least count of the measurement here, uh, we need to do 1 main scale division minus 1 vernier scale division, which is nothing but zero point 0.1 minus 0.09, right? 0.09, I think, yeah, it will be a 0, right? So 0.09, once you will subtract, so you will be getting 0.01 centimeter over here. That is the least count of this scale. But there is an error also. The error is already given to us as 0.1 centimeter, right? So if I tell you how to take the reading of this, I think you know very well the reading. So whatever main scale is reading, that plus the number of vernier scale divisions which are matching with the main scale division, if that number you exactly know and it is given as 8 in this question, that has to be multiplied with the least count. That is the actual reading that will be happening, but this will be with error, right? Because error was already there. So error we already know, it was initially 0.1 centimeter when the jaws were closed. So I know this will be 5 plus 8 is given as this number into 0.01, right? The answer should be 5.08. Okay, 5.08. Okay, so 5.08 centimeter is with the error. So without error they are asking you, so 5.08 means you have to subtract the error which was prevalent from the starting. So that answer should be right, this one. I think that is there in this option. So yeah, so that is the answer. Now let's discuss the 16th. I think you are getting these questions. These are very direct theoretical questions. Just you have to use the right concept, right thing that you have learned and put the values and you are getting the answers. ओके, तो आप लोगों को ये बहुत इजी लगना चाहिए क्योंकि चीज़ें बहुत डायरेक्टली पूछी गई हैं, राइट? सो लेट्स कंटिन्यू इन द सेम फैशन. Okay, in some appropriate units, time and position of a moving particle is given by t is equal to this. then acceleration of the particle is, okay, t is equal to x square plus x. Okay, let's think about it. T is equal to x square plus x. Okay, if I try to do some kind of a differentiation here, I know this is what I'm getting, right? Which is nothing but my velocity. I know the differentiation of this again, if done properly, will give me what? But this is with respect to time, so either I can do this or I can do v dv by dx. That is one more option with me. So I know already about the v, so the v part can be written as 2x plus 1, right? But dv by dx again, if I do properly, I think I will have to apply the chain rule. So if I do that, dv by dx I can easily calculate will be minus 1 upon 2x plus 1 whole square multiplied by 2, because I am applying a complete chain rule about getting this differentiation dv by dx. So I think the answer we are supposed to get is minus 2 upon 2x plus 1 whole square, or no, it should be whole cube, right? So the power should be whole cube. So minus has to be there. How can it be x plus 2? That is not fine actually. X plus 1 is also not fine. I think the only option we are getting correctly over this picture is this, right? Okay, so I think this question was asking you that instead of using dv by dt, you have to use dv by dx, right? Nothing special. Okay, so this is again a photoelectric question which is asking you that choose the correct graph which shows the variation of photoelectric current with the intensity, and photoelectric is this is also same photoelectric current with the frequency. For frequency, I think this graph C graph can be easily rejected, because minimum threshold frequency is required to start ejection of electrons. So I think the correct option from these two will be this one, right? Okay, just a second. So this is the correct one. This can be rejected, right? This has been rejected. Now this is also surprising that something is remaining totally constant in this case. You know that mostly 17th question I am discussing, right? Intensity is controlled by number of photons, because if you are plotting a graph between photocurrent versus intensity, definitely your focus won't be on disturbing the photons frequency, because otherwise you will be changing frequency and also changing these two things together, right? So instead of that, generally your focus in increasing the intensity is number of photons. So once you increase the number of photons, definitely if the current is already coming out from a metal, so if number of photons are increasing, so definitely the photocurrent, if I use again a symbol, let's call it as, let's say, I dash, so that these two things don't look exactly same. This is for intensity and this is for current, right? If I plot a graph between them, definitely it has to increase. So from these two, if I just go on to choose the right option, that constant one must have been wrong, right? So based on this, I can remove this one and choose this one, right? Because you know that once the intensity, that is the number of photons, are almost zero, so then current also will be coming out zero. There is no such dependency on minimum something like frequency here. Yeah, but it will be a linear variation, because once you are linearly increasing your intensity, same will be the effect on the count of electrons coming out. So it will be a linear kind of a relation. So we can consider it to be almost right. So I think A and D should be the right option. So fourth one, right? Okay, so 18th is asking you a particle of mass m is moving around the origin with a constant force pulling it towards the origin. If Bohr model is used to describe its motion, then the radius of the nth orbit and the particle speed depends on as okay, the radius relation and velocity relations you have to clearly tell. Okay, Bohr model. Okay, some hypothetical situation has been given here, so they are asking us to think about some particle doing circular motion under a constant force, right? And this is a centripetal force which will be a constant to keep it in circle, right? So I know that F is equal to mv square by r, which is a constant according to the situation. And using the Bohr model, I know this situation is also going to be valid. Mvr is equal to nh by 2 pi, that is the angular momentum part. Okay, so if that is also true, now they ask me to predict v and r relations in terms of n, right? So I think there are two equations, two variables v and r. So if I want to solve any of these, I can easily solve. So how to solve, let's say, about the v? I think I can just multiply these two together. So m square v cube r by r will get cancelled, right? Nothing else otherwise seems to be there. So constant multiplied by nh by 2 pi. In this situation, if I take all the constant together, n cannot be a constant, right? And mass also will be a constant. I know v cube has come out to be proportional to n, right? Because r and r are not there in the picture because of such multiplication. So v seems to be proportional to n to the power 1 by 3. Let's see the options. Okay, so this option is also valid. This option also seems to be valid. Now we have to differentiate based on the r. Okay, so to solve the r in this picture, I think what I can do best is I can square this below 1 and then divide these two, because then v square will go away, right? Mv square by r is equal to constant that divided by m square v square r square, that on the other side will have n square h square by 2 pi whole square, right? Yeah, I think that is what is working here. So that makes v square go away. So I know the overall power of r in this situation is becoming like 1 by r to the power 3. That is going proportional to n square. So I think r cube is going proportional to n square. So r is going proportional to n to the power 2 by 3. So I think that option should be the answer. I think this option is going well, right? So I think these were the next 9 questions that we were supposed to discuss. So we'll be continuing the discussion in the next video. So similarly, like very soon we'll be finishing up all the questions. Thank you.